Section 9.3 deals with exponential functions. We want to use the characteristics of exponential functions. We want to sketch the graphs of exponential functions using transformations, and we want to solve exponential equations by relating the bases, as well as solve applications of exponential functions. So let's start with the basic definition of an exponential function. It's a function of the form f of x equal b to the x, where x is a real number and b is greater than 0, such that b is not equal to 1. So b is bigger than 0 and different from 1. The constant b is called the base of the exponential function. And let's look at the characteristics of an exponential function. The domain is all the real numbers, and the range is all the positive numbers. The graph has one of two basic shapes. If b is bigger than 1, the graph has the shape we see on the left. If b is less than 1, but remember b has to be bigger than 0, then we have the shape we see on the right. Both graphs intersect the y-axis at the point 0, 1. So 1 is the y-intercept for both graphs. On the left, though, b to the x goes to infinity as x goes to infinity. On the right, b to the x goes to 0 as x goes to infinity. On the left, b to the x goes to 0 as x goes to negative infinity. And on the right, b to the x goes to infinity as x goes to negative infinity. What these two statements tell me, the two statements on the left tell me the graph is increasing. And that essentially means as x gets bigger, so does y. The two statements for the graph on the right tell me that the function is a decreasing function. As x gets bigger, y gets smaller. Both functions have y equals 0, which is the equation of the x-axis, as a horizontal asymptote. On the left, it's the negative x-axis, that's the horizontal asymptote. On the right, it's the positive x-axis. The function is 1-to-1 in both cases. What's important about that is that the inverse of this function is also a function. So let's take a look at exercise 1 from section 9.3. We are asked to sketch the graph of f of x equal 4 to the x. And we're going to do that by filling in the table that's given. So notice that if x is negative 2, we get 4 to the negative 2, which is 1 over 4 squared, which is 1 over 16. If x is negative 1, we get 4 to the negative 1, which is 1 over 4, which is simply 1 over 4. So these are the values that are going in the table. 1 over 16, 1 over 4, and if x is 0, we get 4 to the 0, which we've learned is simply 1. 4 to the 1 is simply 4. And 4 squared is 16. Okay, so this is so in other words, we're going to be plotting these points. We're going to plot the point -2, 1 over 16, -1, 1/4, 0, 1, 1, 4, 2, and 16. So that's what we'll need to plot in order to graph this. And in this question, you have a choice of graphs. But let's just do a real rough sketch. So in other words, when x is -2, we're very, very close to the x-axis. When x is -1, we're still close to the x-axis, but we're a little farther away. When x is 0, we're at 4. And then when x is 1, when x is 0, we're at 1. That's what I meant to say. And when x is 1, we're at 4. And I don't know, let me move that up just a little bit. All right, so we're up at 4, and then I don't even have enough room to show that when x is 2, we're at 16. This is increasing so rapidly that you need a lot of graph to show this. So the graph would look something like this. All right, so we know that's what we're looking for when we go to look at the graph choices. And we can see that the only thing that looks anywhere close to this is choice C. So we will select that. And we see that when x is 1, we're at 4. When x is 2, the graph is all the way up to 16. Obviously, A and B don't even have the right shape. When B is bigger than 1, we know we're going to have this curve that's increasing, and notice in this fashion. And notice that even though this graph is increasing, it's increasing too slowly. When we're at 2, we're not even up to 10. And we saw from the table when we're at 2, we need to be at 16.